All right, Math 2, we have the last lesson of the semester, 7-10, areas of regular polygons. So our question today is, how do you find the measure of a central angle in a regular polygon? So we got a lot of terminology that we need to cover so that you can answer that. Let's talk about a regular polygon first. So regular polygon is a polygon. So polygons are where you've got a shape that is made up of sides that are straight, so no curves. So it's a polygon where all the sides are congruent and all the angles are congruent. So all sides and all angles are congruent. That's what it means to be regular. Okay, so here's a regular triangle. And basically a regular triangle would be equilateral because all the sides are congruent and all the angles are congruent. Now, anytime we have a regular polygon, it fits perfectly inside of a circle. So the vertices of the polygon will always touch the outside of the circle, and the center of the circle will always be in the very center of the shape. So there's a regular triangle, and over here we've got a regular hexagon. So the hexagon fits perfectly inside a circle, and the center of the circle is the center of the polygon as well. Okay, so we've got three different things that we need to talk about inside of these regular polygons. First thing is a radius. A radius of a segment is just like the radius of the circle, or the radius of the polygon is a radius of the circle. Basically, you just go from the center to a vertice, and that would be a radius of the polygon. So inside of a regular triangle, an equilateral triangle, it would have three radii. Is that the plural? I think that's the plural. So a circle a regular triangle has three radiuses there. Okay, then a regular hexagon, of course, would have a ton of radiuses. Well, not a ton, it'd have 6 of them. So all of these would be radii. Here, I'll just go all the way across. That would have been smarter. Just have to do this 3 times. All right, so there we've got all of our radii. So that's a radius of a polygon. It just connects the center of the circle to one of the corners or vertices. All right, a central angle. A central angle is formed by 2 vertices and the center of the circle. So basically, if you take 2 radii here, this would be the central angle. Now we know that a circle has 360 degrees. And in this case, we can just take the central angle can be found by taking 360 and dividing by the number of sides. So on top here, we've got 360 degrees. And then if we divide it by 3, because there's 3 sides in the regular triangle, we would have a central angle of 120 degrees. So this would be 120 degrees, and that's our central angle. For the regular hexagon, again, we do 360 and divide by the number of sides. So 360 divided by 6 sides, and that comes out to 60 degrees. And that's our central angle for a regular hexagon. All right, so we've got radius done. Their radius is just the center to a vertex. We've got our central angle down. Last thing is the The apothem is a segment that connects the center, so the center of the circle, to the midpoint of a side. So basically it's a perpendicular bisector. So if I wanted to do an apothem on the regular triangle, the apothem would start at the center and then it'd go to the midpoint. So it's cutting this into two congruent parts, and it's perpendicular. So it's a perpendicular bisector. So that one would be the apothem. So there's an apothem there. Okay, so if I go over here on my regular hexagon, the apothem would go from the center to the midpoint over here. So center to midpoint, I'm just going to eyeball it. I think it's about right there. Good enough. So we're going to say that this is the same there. And that will be the apothem right there. All right, last thing we got is this right here is half of a side, because the apothem cuts the side into two congruent parts because it's a perpendicular bisector. And then this one over here would be half of a side. Now what we have are these right triangles, and we're in a section that covers right triangles. And what we're noticing about these right triangles is I can now actually find out how many degrees everything is in the right triangle. Now notice up here, I had 120 degrees for my central angle. So this big angle right here should be 120. But my apothem cuts the central angle in half, because not only is it cutting this side in half, it's also cutting the central angle in half. So this is a 60-degree angle up there, because we got 60 there and 60 over here. So the apothem cuts it in half. And then over here, since this is 90 and that's 60, this must be 30. So we have a 30, 60, 90 if you take your radius, your apothem, and your half side. And we've done 30, 60, 90 triangles before. Remember, those are the triangles that are the B, 2B, and B root 3. So we're going to use that in this section. Over here on this other one, since we've got the central angle is 60, so here's 60, the apothem cuts it in half, we get 30 degrees up here, because the central angle is cutting those in half. And that means this is a 30, 60, 90 triangle as well, just with the angles switched over here. So it's 30 on top and 60 on bottom, whereas this is 60 on top and 30 on the bottom. So on this one, the half side would be B, the radius is still 2B, and the apothem is B root 3 on this one. All right, we're going to use that in a little while. So basically, when we're doing these shapes, we're really going to break them down to this right triangle here. The right triangle made from the apothem, the radius, and the half side. You'll see why in a little bit. All right, now let's talk about the actual area of a polygon. The area of the polygon can be found by the equation 1/2 apothem times perimeter. Okay, so if I take any regular polygon, find its apothem, and then multiply by the perimeter of the shape, so add up all the outside sides, that should end up being the area of the entire shape. Now here's why that happens. Okay, let's think about this square that we've got. It's a regular quadrilateral, which is a square basically, because all the sides are the same and all the angles are 90. Let's look for its central angle here. Its central angle should be 360 divided by 4 sides, which is 90 degrees. So this should be a 90-degree central angle right there. Okay, if we made the apothem on this one, remember the apothem would go to the midpoint. So there's my apothem. This was the radius right here. And then down over here, this is half of our side length. So in this one, since the central angle is 90, the apothem cuts that central angle in half, so that's 45 degrees. This was 90 down here. So this one is a 45, 45, 90. Now, if you look at it, the square is broken down into 4 triangles. So one way to find the area of a square is I could just find the area of each of these triangles and add it together to find the area of the entire shape. So I can say, okay, so one of these triangles, if I wanted to find the area of it, I would do, the triangle area is 1/2 base times height. So the height here is the apothem, and then the base is the side. So this area of this triangle right here is a triangle, so it's 1/2 base times height. The base is the side, the height is the apothem. And I've got 4 of them, and all 4 of these are exactly the same. So I could say, okay, plus another one. Oops, side. So this triangle plus this triangle, so now I've got 2 triangles, plus a third triangle. And then I've got a 4th triangle there. So basically I've got 1/2 the apothem times each of the sides. Now each of the sides, if I add up all 4 sides, the 4 sides are the perimeter of the shape. So that's why this formula works. It's 1/2 the apothem times the side plus the side plus the side plus the side, which is the perimeter. And it works for any regular polygon. So in this one, we'd have 1/2 the apothem times the side plus the side plus the side. That's the perimeter of this one, 3 sides. 1/2 of the apothem, we've got 6 triangles in here. Well, I've got 6 sides. So side plus side plus side plus side plus side plus side, that's the perimeter of the shape. So we're going to find our area by just taking the areas of each individual triangles in here. And the triangles are going to be made from this little apothem that we have here and our side length. All right, so I don't know if you've noticed it, but we've got 30, 60, 90 here, 30, 60, 90 here, and in a square we got 45, 45, 90. So these are our special right triangles. So remember on a square, this one would be A, and A times root 2 for that one. All right, now we're actually going to do some problems. Next one. All right, so I've got an equilateral triangle, and it has a side length of 12, meters. And I want to find its radius, its apothem, its perimeter, and its area. Now, why did I not draw an equilateral triangle? Why did I draw this triangle over here? This is a right triangle. Well, what I'm going to do is I'm only going to take this little section right here and work out this section. So I'm only taking the 30, 60, 90, and I'm going to use the radius, the apothem, and the half side. I'm not going to draw the whole triangle. I don't need that. So this right here represents just this small section right here. So I know that in this small section, it's a 30, 60, 90 triangle. And this part over here is the apothem. This part right here is my radius. And then this bottom part here would be my half side. So I'm not going to draw the entire equilateral triangle. I'm only drawing this little bit of the triangle down here. Okay, so it tells us our side length is 12. Oh, before we get to that, let's write that this is B. This is B root 3, and this is 2B, because it's 30, 60, 90. Okay, so we know that our side length is 12, so an entire side is 12, so a half a side must be 6, because an entire side would be 12. All right, let's find the radius now. Well, if we know that the B root 3 side is 6, I can find out what B is. So B root 3 equals 6. And then we know that we're going to divide by root 3 here. The root 3's reduce. I got a little bit of a problem. I'm not allowed to have a radical in the denominator. So I multiply the top and the bottom by root 3. So that gives me that B is equal to 6 root 3, because we got 6 times root 3 on the top. And then root 3 times root 3 we know is just 3. And then what we can say is, okay, 3 goes into 6 2 times. So B is equal to 2 root 3. I just found, since B is 2 root 3, I found my apothem, because my apothem is B. So I know this answer, 2 root 3. Okay, now I want to find out what my radius is. My radius is 2 times B. So that's 2 times, and B we said was 2 root 3. So 2 times 2 root 3 is 4 root 3. So my radius is not 2, 4 root 3. My perimeter. Well, I know that I've got 12 for each side, and it's a triangle, so there's 3 sides. So this would be 3 times 12. 3 sides, and each side is 12. That's going to be 36. Now we can find the area of our shape. Our area is 1/2. Remember, it's 1/2 the apothem times the perimeter. So what was the apothem? 2 root 3. What was the perimeter? We found out it was 36. So 1/2 times 2 root 3 times 36. Now you can multiply in whatever order that you want. So 1/2 times 36 would probably be the easiest way to do this. So 1/2 times 36 is 18. So this would be 2 root 3 times 18, because I took half of 36. And then 2 root 3 times 18 is 36 root 3. And that's my area. So we didn't draw the whole triangle. We only drew the part with the apothem, the half side, and the radius. We know that the central angle, because remember this is a whole triangle here, the central angle over here was 120, because you can do 360 divided by 3 sides, and you get your central angle of 120. The apothem cuts it in half, that's why this is 60 up here. It's a 30, 60, 90, because the apothem is the perpendicular bisector, so that's 90 degrees there. So now we've worked it out. Okay, next one. So I've got a square here. Of course, this is not a square, because remember what we're doing, we're breaking this down so that we're only doing this little part of the square. So we're only doing this little section of the square here. So this is 90 degrees right here. Now in a square, remember that the central angle of the square is 360 divided by 4, so that's 90. So this whole thing would be 90 here, but then the apothem cuts it in half. And so this becomes 45 degrees. That means this is 45 degrees, and it's a 45, 45, 90. So this is my apothem. This is half the side length. And this is my radius. Okay, it's a 45, 45, 90. So I know that's the pattern of A, and A times root 2 for my hypotenuse. Okay, they're telling me in this one that my radius is 8 root 2. So this over here is 8 root 2. So if I know that A root 2 equals 8 root 2, I'm going to write that equation down. A root 2 equals 8 root 2. Okay, I want to find out what A is, because A would be the half side, and it would be the apothem. So I'm going to divide both sides by root 2. Cancels. And then look what happens over here. Root 2 divided by root 2. Those also cancel. So I'm left with A is equal to 8. So that means the apothem is equal to 8, and the half side is equal to 8. So I've got my answer for my apothem. The apothem's 8. Side length. Okay, remember this is only half the side. So if half the side is 8, the entire side is 16. Perimeter. It's a square, so there's 4 sides. So 4 times each side, which is 16. And 4 times 16, of course, is 64. So I got 64 for my perimeter. Area. Remember, it's 1/2 apothem times perimeter. So I would do 1/2 apothem's 8, perimeter 64. So half of 8 is 4. And then 4 times 64, 128, 256, 256. And there you go, 256 feet squared. So these were all in feet, but the area was in feet squared. Okay, last one, regular hexagon. Okay, so in a regular hexagon, again, we are only doing this little section right here. Okay, so this over here is a 90 degree. We know since it has a central angle of 60, because it's 360 divided by 6, we know that the central angle is 6 degrees. This is not the central angle. This is half of the central angle. Remember, the apothem cuts the central angle in half. So that means this up here is 30 degrees. And that means this is a 30, 60, 90 triangle. So this is the apothem. This is the half side. And this is the radius. I mean, if you want to draw the whole entire hexagon, you could, but I only draw this little part of the hexagon. All right, so this is a 30, 60, 90 triangle, so let's write down our pattern. The half side would be B, the radius would be 2B, and the apothem would be B times root 3. Okay, so they tell us that the apothem is 12 root 3. So, okay, so this side is 12 root 3. So, if B root 3 is equal to 12 root 3, I can find out what B is by dividing by root 3. So root 3 divided by root 3 reduces. And then over here, root 3 and root 3 also reduce. So I'm left with B equals 12. So now I know that my half side is 12. And then if I do 2 times 12, my radius would be 24. All right, so my half side is 12, so an entire side would be double that, which would be 24. Which, what do you know, is the same thing as the radius. The radius is also 24. What's the perimeter? The perimeter would be 24 times the 6 sides, because it's a hexagon, it has 6 sides, times the side length of 24, and then 6 times 24 ends up giving us 144. So my perimeter is 144. Okay, then to find the area, it's 1/2 the apothem times the perimeter. So area would be 1/2. My apothem, they gave it to me, it was 12 root 3. And my perimeter is 144. Okay, so you've got options here. You can take half of 12 root 3, which would be 6 root 3. Or you can take half of 144, which would be like 72. Let's just take half of 144. So 12 root 3, and then half of 144 is 72. Remember, you don't take half of both of them. You just take half of one of them. Okay, so 72 times 12 is 864. So our final answer is 864 root 3. And then that's in inches squared. Now, if we wanted to find like the decimal answer to this, you just do 864 times the square root of 3. And it comes out to 1496 and about 0.5. So this is approximately 1,496.5 inches squared. This is the exact answer. This is the rounded answer. All right, that is all I got for you, my people. Enjoy. Make sure to answer this question. How do you find that measure of the central angle? Okay, so how do you find it? It should be somewhere in the notes. So answer that question as a summary for your notes. That's all I got for you. Semester, that's it. No more notes. Just have to take the test. Congratulations, you made it. Bye-bye. Math hard.